Right, the final thing with this section is to use a correlated subquery in the where clause. Now previously we've just used it in the from clause. So you can see this correlated query gives us the number of transactions and the total amount superimposed on top of the table employee. But what if we wanted it the other way around? We wanted all of the transactions and do a correlated subquery on the table employee. Well, this is where we use the where exists. So just to start this in perspective, we have 2,486 rows, but we only want that where there exists an employee number from table employee, where the employee last name is like Y%. And here's the correlation. The employee number in the outer query is equal to the employee number on the inner query. So that's the equivalent of the join, and you've got to have that inside. Otherwise, like we saw last time, where we didn't have this where, we just had the count of absolutely all of the table. We had to have this where to join it together so that we could just have, for each individual row, that one particular employee number going into the where. Here it's the same thing. For each particular row in the table transaction, we put into the where exists the table transaction dot employee number and only select the employee number, or indeed anything, where it exists in the table transaction and the table employee on that row. So in other words, what's going to happen is that it's going to go into the first row and say, does it select this everything where it exists, that select employee number, that there is an employee number in table employee where the employee last name is Y%. Well, so far, that exists. There does happen to exist at least one row where the employee last name starts with Y. And that the employee number is equal to the employee number in the row we're talking about. So the row we're talking about is this one, first one, with employee number 658. Does 658 exist in this small group? The answer is no. So that where exists becomes false, so it gets suppressed from the select statement because the where condition fails. So it goes down all of these. Now we can show this also as an extra column in the select criteria. So I'll put this as does it exist? And I'll just do something with the formatting. So this doesn't exclude them, but it puts a null where it doesn't exist, and where it does exist, it puts the employee number. So that's going to tell you that when it's in the where clause of this outer query, it's going to suppress them. It's not going to be part of the where. So let's put that back into the where exists. There it is. So now when we run this correlated query, we just get the 4 employee numbers and we get the 8 rows in which they exist. Now, it looks like a variant of the query that we started off in about lecture number 3 or lecture number 4 of this session 6. Is it any better in terms of speed? We saw that the correlated query in the select statement is quicker. So let's have a look. Display estimated execution plan? No. They both take the same amount of time. 50, 50. And that's understandable because what we had up here in the select is that it was only running 4 times. Whereas down here, it's running for every single row in table transaction. So what actually happens is that the computer evaluates that and sees it as identical to this second one. You'll see that the execution plan, or the estimated execution plan, is identical. So it works it out as being the same. So no, there is no faster answer here. So why am I telling you that this is possible? Well, simply because you don't know what you're going to be tested on, and I don't know what you're going to be tested on. And even if you weren't doing the exam, I don't know what you will come up against with somebody else's writing. It may simplify the process enormously if you use a where exists. But for instance here, you don't need this join. You just need this and instead. So it gives you the same things, just in different places, which you find easier to comprehend. And the advantage of this, of course, using a subquery, is you can always execute it as long as you avoid the correlation. You can't run it with the correlation on its own as the inner query, because you'll get an error message. But it can help to clarify SQL Server. And if it helps clarify TSQL, must be worth knowing. And finally, just a reminder that you can use not with exist as well. So here we've got all the table transaction up, only employee numbers 126 through 129. But we can put a not exists and have the entirety of table transaction, which was 2,486 rows, minus those 8 rows. So at 2,478 rows.